This is the second part of the solutions for the chapter review for chapter 3 test, part 2. So let's take a look at number 8 here. And it says explain whether a triangle with side lengths 15, 20, and 25 is a right triangle. And so we're going to use the converse of the Pythagorean theorem, which states that we're going to take the 15, square it, the 20 and square it, and see if it equals the longest side. And the key is make sure that this is the longest side, and it's by itself called the hypotenuse. So we go ahead and multiply this stuff out to get 225. 20 squared makes 400, and 25 squared makes 625. So when we add these two numbers together, we do get 625. And since these two numbers are equal, we can state that it is a right triangle. So here's the little phrase that you'll use. You'll say since 15 squared plus 20 squared equals 25 squared, then the triangle is right. Well, let's take a look at our next problem, and we are on to number 9 on the back side. And it says to approximate the square root of square root of 60 to the nearest hundredths place, or not actually the nearest. We're just going to approximate it to the hundredths place. So it's not exactly at the hundredths place, but it's going to show us which tenths place it's in between. So what we do is we look for the perfect squares that 60 is between. So we have the square root of 49 and the square root of 64. 7 is the square root of 49. 8 is the square root of 64. So then I need to see which one it's closer to. So I'm going to subtract. And so I'm going to do 60, and I'm going to subtract 49 from that. And when I do that, I end up with 11 spaces away. And if I did 64 minus 60, you see how you're only 4 spaces away. So it's a lot closer to 8. And so numbers that are closer to 8 are like 7.7 or 7.8. So that's what I'm going to try first. So I multiply out 7.7 together, and I end up with this. I end up with 59.29. And then if I tried 7.8 times 7.8, I end up with something just over 60. I end up with 60.84. So you see how it's in between these two numbers. Well, the numbers that are in between 7.70 and 7.80, that would be 7.75. So it tells me, doing this tells me that that number, the square root of 60, is in between 7.7 and 7.8. So this next one, we need to write it as a reduced fraction. So we're just going to take the part that repeats and set it equal to x. We're going to multiply this by 100. So I'll multiply this side by 100 and this side by 100, and I end up with 100x equals 15.15 repeating. So from that point, I can go ahead and take away x from all sides and take away the part that repeats as well, and that'll cancel that out, leaving me with 99x equals 15. So from that point, we can divide by 99, and when we do that, we end up having a common factor of 3 we can take out from these two numbers. So our answer is 5 over 33. So the next one, we have to reduce this, and so all we're going to do, if it's a terminating decimal, is write it over the place value of the last digit, which is in the thousandths place. And so when we go ahead and reduce this, I'm going to divide it by 25 over 25, and that gives me 5 over 40. And that reduces one more time. When I divide by 5 over 5, I end up getting my answer of 1 over 8. So these are rational numbers. Anytime we've got a repeating decimal or a terminating decimal, we can write them as fractions. Numbers that cannot, these are irrational numbers. So here are our rational numbers. And then this we call an irrational because the square root is not perfect and we can't write it in an exact form to come up with the fraction form. Well, here it says the one of the sails of a sailboat is in the shape of a right triangle, and we're supposed to find the height of the sail. And so this says, let's call it x, but notice it's combined with that right angle. So these are the two legs of the right triangle. The side opposite is the hypotenuse. So I do this, x squared plus 12 squared equals 20 squared. And we continue on, x squared plus 144 equals 400. Do some subtraction. Take away the 144 from both sides, and we end up with 256. And so from that point, we can go ahead and take the square root of both sides, and that gives us our value of x, and x ends up being 16. So we'd say that the height of the sail is 16 feet. Well, here it says, is the triangle with side length 7, 9, 12 a right triangle? And explain. So we just take the two sides that are the shortest and square them and add them together. See if they equal the side that's the longest. And so we go ahead and do that work, 49 and 81, and see if it equals 144. Well, when we go ahead and sum these two numbers, we end up with 130. And 144 does not equal 130. So since these two numbers do not equal, what we can say is, and then we can write that out, 7 squared plus 9 squared does not equal 12 squared, then the triangle is not right. So it's not right because the converse of the Pythagorean theorem did not work. Now we're supposed to figure out which one is it closer to, 6 or 7. Well, let's take the square root of 38. And we see that the square root of 36 is 6. The square root of 49 is 7. So you can see how much closer 38 is from 36. So I would say it's closer to 6. So closer to 6 than 7, because 38 is closer to 36 than 49. And those are the square roots that we'd end up having. So closer to 6, because the square root of 36 is closer to the square root of that 36 than the square root of 49. So now we're having to explain whether each of the followings is rational or irrational. So we look at the number 2, and this is a rational number. And it's rational because we can write it as a fraction, and that would just be 2 over 1. And then we see that 1/5 is also rational, and it's rational because it's already in the fraction form. The square root of 10 is irrational, and it's irrational because it's not a perfect square. And then we have the 0.3 repeated. And this is a rational number, and it's rational because we can write it as a fraction. We can write as a fraction. So looking at the next one here, it says find a number greater than 1, less than 1,000. It's both a perfect square and a perfect cube. So if we look at the square root of 64, that is 8, and the cubic root of 64 is 4. And so that's our example there, is that if I have a cubic root and a square root, and they're both less than 1,000, but both perfect, and that is what we end up having there. And the next one says, explain how you know the square root of 2 is less than 2 times the square root of 3 without performing any calculation. Well, I know the square root of 2 is less because the square root of 2 is bigger than 1. See, if I look at it, the square root of 1 is 1, the square root of 4 is 2. And so I know the numbers between these two values. So since the square root is larger than 1, doubling it will produce a larger value. So if you double a number that's bigger than 1, it's going to always end up being a bigger number. Doubling a number smaller than 1, a fraction, is going to end up giving us a smaller value. Well, let's take a look at our last problem here, and it's this one where it talks about Ed walked his dog 5 blocks to the 5 blocks east, 2 blocks, and then stopped and drinking fountain and so on. Actually, we're going to go ahead and finish this up on a different tutorial, so check out part 3 for that one.